Hello all, welcome to the playlist of network analysis. So in this session, I'm going to discuss the important problems which is belong to the source reduction and the source shifting in the first module of network analysis. So these are the previous year question paper. You can go through once and try to solve the similar kind of problems. So I feel these questions can be expected for your university examination. So first of all, please read the question carefully. Using source reduction technique, solve the node voltage of network shown in the figure. So we have a circuit diagram which is given. So what you are supposed to do using source reduction, you need to calculate the node voltage of network. That is the aim of the experiment. Sorry, aim of the question. So identify what are the current sources available, what are the voltage source available, what about the branch resistance, and try to remember provide the branch name. If they haven't given, kindly give the name of the branches. So everybody, please listen here. First of all, what you can see, 45 ampere, which is flowing over here. Okay. So what I will do. So here we can do the some minor arrangement you are supposed to do. So the arrangement is 45 ampere. I am going to keep like this 45 ampere. Then 2 ohm and 5 ohm I'll be keeping in this particular fashion. 45 ampere you can see one is in the upside, current source is in the upside, and other one is on the opposite side. It is kept like this. So 45 ampere, I'm going to make some arrangement. 45 ampere and 2 ohm, then 45 ampere and 5 ohm. Okay, this combination I'm going to convert. The first part you can observe here, the first part. Secondly, what I am going to do, so I'll be using the voltage, current to voltage source transformation. 45 ampere parallel to 2 ohm resistor is equal to 2 ohm resistor series with the corresponding voltage. Okay, now the dotted portion I'm going to reduce. Let me reduce the dotted portion. Once again, I will show you. So given the circuit diagram, you can note down parallelly. So 45 ampere parallel to 2 ohm resistor, I am going to convert. Even 45 ampere parallel to 5 ohm resistor also, I am going to convert. So now please see, 45 ohm, 45 ampere parallel to 2 ohm is equal to 45 into 2 means 90. That means 90 volt. See, voltage is nothing but current into resistance. Current is 45 ampere. Here it is given. Resistor is 2 ohm. In the opposite side, current is how much? 45 ampere. Resistor is 5 ohm. Therefore, voltage is nothing but 45 times 5 ohm. Right. So, I'm going to convert voltage source series with the resistor. Here 45 into 2, that is 90 volt, series with the resistor 2 ohm, that is given here. On the opposite side, 45 into 5, how much it is? 225, that is series with the 5 ohm. That is what I have done it. Then remaining I kept as it is, that is 8 ohm and 30 volt. Similarly, in the bottom side only 10 ohm. Then other side, what I will do? 30 volt series with the see, here also I am going to do one adjustment. This 30 volt I am going to connect in the first portion. See, 30 volt, that is series with the 3 ohm. Here that 30 volt is common. Therefore, what I will do, I am going to do the source shifting. 30 volt I am going to keep it another branch. So this particular branch will kept empty. That is in the form of a short circuit where the above like a branch, that is DA branch, I am going to shift the source. That is called a source shifting. I have a provision to shift the source, that is 30 volt series with the 3 ohm. Okay, see, 30 volt series with the 3 ohm, what I will do? I'll be converting in the form of current source parallel with the resistor. Current source is how much? 30 is the voltage, 3 is the resistor. So I is equal to V by R, 30 by 3. That is nothing but 10 ampere. 10 ampere parallel to 3 ohm. Then 6 ohm I kept as it is. Okay, now you have to do the simplification. How to do the simplification? All of you please look at here. 2 ohm and 8 ohm are connected in series. Therefore, 2 plus 8 is nothing but 10 ohm. Similarly, 5 ohm and 10 ohm are in series. 5 ohm is here, 10 ohm is here. Both are in series. Therefore, total resistor is equal to 15 ohm. Then you do apply source transformation once more. Okay, once more I am going to apply the source transformation. So 2 plus 8 is nothing but how much? 10. Then 90 and 30. Look at this, 90 and 30. I'm going to simplify 90 and 30. Okay, so what could be the like a result? 90 and 30. So 90 polarity you can take care. Okay, so Now try to simplify it. 90 and 30, both are opposite polarity. So take the difference. 90 minus 30, that is equal to how much? 60. So the 60 and 2 plus 10. 10 no, 60 and 10. 60, like a 60 volt series with 2 plus 8, 10 ohm resistor. Okay. 60 volt divided by V by R, right? V by 10. So 60 by 8 plus 2, that is 10. That is equal to 6 ampere. See, it is going to convert it as 6 ampere parallel to 10 ohm resistor. Again, I applied the source transformation. In the bottom side, you can see like 5 plus 10. How much it is? 15. This is 225 volt. So 225 divided by 15 is how much? So you are able to get 15, right? So 10 ohm and 15 ohm, that is going to become parallel. 6 ampere is in like a clockwise direction, where 15 ampere is in anti-clockwise direction. So this portion I have completed. Now looking at the right side, 10 ampere and 3 ohm. See, 10 ampere and 3 ohm both are parallel. That is also parallel with the 6 ohm resistor. So I'll be writing like this. 10 ampere, then 3 ohm and 6 ohm. Now look at this. 3 ohm and 6 ohm, both are in parallel now. So 3 into 6 divided by 3 plus 6. How much it is? 3 into 6 means 18. 6 plus 3 means 9. 18 by 9 is how much? 2 ohm. Okay, so here I got 2 ohm. Then here 9 ohm resistor is available. So 2 ohm and 9 ohm. Then what I will do? So this 2 ohm and 2 ohm resistor and 10 ampere both are parallel. So 2 ohm resistor parallel to 10 ampere current source is given by 2 ohm resistor series to the voltage source. 2 into 10 is nothing but 20 volt. Here I am going to convert 5 in, 10 into 15. Both are parallel, no? 10 into 15 divided by 10 plus 15. So how much it is? 10 into 15 by 10 plus 15, I am getting 6 ohm. 6 ohm, that is series with 54 volt. 54 volt. So here 54 volt and 20 volt. So 2 ohm and 9 ohm. 2 ohm, 9 ohm, 6 ohm, all are in series. Correct? No, no. 2 ohm, 6 ohm, sorry. 2 ohm, 6 ohm and 9 ohm all are in series. So that you can add the resistor. 6 ohm plus 2 ohm plus 9 ohm you can add. Here the polarity of 54 volt and 20 volt are different. So take the difference. So take the difference. If you take the difference, what you will get? So you can simplify. So you can simplify. Okay. So ultimately, what I'm able to get is BD. I'm able to get. You can apply the KVL. KVL you can apply. Therefore, BD is nothing but VE plus 30. That is minus 42 plus 30. That is equal to minus 12 volt. So this is the way how to solve the ultimate problem. So using the source transformation and the source shifting. Okay. I think you have got an idea about this. There is one more numerical example on source shifting and source transformation. Let's read the question carefully. Reduce the network shown in figure to a single voltage source in series with the resistance between terminal A and B. Use source transformation and the source shifting. They have given the hint also. So as we discussed in the earlier problem, same manner I am going to apply 90 ampere. I am going to shift to the particular branches. Then 60 volt also I am planning to shift to the branches. So here 9 amps I am going to shift in this fashion. 90 ampere parallel to 4 ohm. Same way 90 ampere parallel to 10 ohm. I think you understood. Here in 60 volt I am going to shift to another branch. In spite of that, I'll be keeping this line as a short circuit. Okay. Now what you will do? 4 ohm and 9 ohm. You can convert into like a current source parallel to resistor is equal to voltage source series with the resistor. Same thing I am going to apply. So 4 into 90, the 360 volt, and that is series with the 4 ohm resistor. In this other branch, 16 ohm resistor, that is series with the 60 volt voltage source. Bottom side, 10 ohm and 90 ohm. What is the total voltage? 90 into 10, 900 volt, correct? Then 10 ohm resistor you keep as a series to the voltage source. 20 ohm resistor you are going to keep as it is. And 12 ohm resistor, it will be in this way. And B you are going to keep in this particular fashion. Let us simplify. 4 on 16 or 4 and 16 both are parallel. So 4 plus 16 is nothing but 20 ohm. So 360 and 60, that is polarity is different. So you can take the difference. 360 minus 60 is nothing but 300. So let us simplify 300 and 20. By the way, bottom side you can see 10 ohm and 20 ohm. What is 10 ohm and 20 ohm? That is 30 ohm. Then that is series with the 900 volt. So in the above branch, I am getting 20 ohm series with the 300 volt. By at the same time, bottom branch, I'll be getting 30 ohm series with the 900 volt. Here, voltage to current source transformation you must do. If I do voltage to current source transformation, corresponding to above branch, the first branch which I shown you. So you are able to get 20 ohm parallel to 15 ohm. How it is happened? Why? Because above branch, if you see, voltage is 300, current is 20. So 300 divided by 20 is how much? 15 amps I'm getting. But in the same fashion, bottom side, the 900 divided by 30, that is nothing but 30 ampere. So the thing is, both the current sources are in opposite direction. So if you want to take the difference, means you can take the difference. 30 minus 15, you are able to get. Correct. Now in the right side, you can see 60 volt is series to 6 ohm. So please convert into current source. 60 by 6 is how much? That is 10. 10 ampere parallel to here what you can do 6 ohm and 12 ohm. 6 ohm and 12 ohm, both are become parallel. That means 6 into 12. Here I have written 6 into 12 divided by 6 plus 12. How much you are able to get? 6 into 12 means 78. 6 plus 12 is nothing but 18. 72, sorry, 72 divided by 18 is nothing but 4 ohm. So ultimately I am getting 12 ohm, then 15 ampere, 10 ampere, 4 ohm. So what you are going to do? Here we can say 12 ohm and 4 ohm are in series. Therefore, 12 plus 4, I am getting 16 ampere. 10 ampere and 15 ampere. 10 ampere and 15 ampere. So what you are going to take? So you can take the difference. Okay, you can take the difference. So therefore, see 12 ohm, this become 180 volt, 4 ohm, 40 volt. Fine. So the simple thing I can tell you, 12 ohm series with 15 amp, sorry, 12 ohm parallel with the 15 ampere. So how to convert into voltage source? 12 ohm series with a voltage source. 12 into 15 is how much? 180 volt. The same thing I have written. The first portion, 12 ohm series with 180 volt. In the second portion, 10 ampere parallel to 4 ohm. 10 into 4 is how much? 40. 40 series with the 4 ohm resistor. Therefore, 12 plus 6, I'll be getting 16. Then 180 minus 40, because polarity is different. For 180 minus 40 is nothing but 140. So these kind of problems are most commonly used problem. I request you to solve the problem and try to practice it. So this problem is mainly working on current to voltage source transformation and voltage to current to source transformation. Apart from that, you should know the shifting of the source also. So that is a summary of the numerical example. Hope you can follow it. And if you have any queries, you can use the comment box. I would like to reply back. You can mail me also. Happy learning. Wish you all the very best for your examination. Stay tuned for getting the similar kind of video. Happy learning.